Hi everyone, this is your introductory lecture video for section 1.4, Radical Equations. Now before we get started with this section, there are some important properties of roots and powers that we must remember. Okay, let's suppose that I'm taking the nth root of a variable. So here I'm talking about this first property here, this guy. So let's suppose I'm taking the nth root of a variable, and then I decide to raise that entire left-hand side by the index of the radical. So the index of a radical, this is telling you which root you're taking, right? So if I was taking a cube root, that n would be 3. Fourth root, that n would be 4. If you exponentiate a radical by the same power as the index, this will get rid of the radical. So the nth root of x raised to the power of n is equal to x. What else do we have to remember? We talked about this briefly on Tuesday. If you're taking a root of a sum or a difference, the root does not distribute over the sum and difference. The same thing is true of powers. If I have x plus y or x minus y raised to the power of n, I cannot distribute that power into the sum or the difference. So now let's talk about this section. Let's suppose I gave you a problem like this one here. 2 plus the square root of 12 minus 2x equals x. The question that we want to answer is, how do we solve for the variable x? So this is the main topic of section 1.4, where we are solving radical equations. We have an equation in which the variable x is inside a radical, and we want to solve for x. So what do? So there are a few steps that we will have to follow. Right now on the screen, you only see 2 of those steps. Here are the steps that we're going to take to solve these types of problems. Step 1. If the equation has one radical expression, you will isolate the radical. This means to get the radical all by itself on one side of an equation. And then what? You need to raise both sides of the equation to the index of the radical. And I wrote down an example right below this. So you'll see that in this little example, I have the cube root of x plus 1 equals 2. That radical expression is by itself. In order to get rid of the radical, we must raise both sides of the equation to the index of the radical. So if I have a cube root, I raise both sides to the third power. And then what? You need to simplify everything after you have raised both sides to the power. You will move everything to one side and then solve for the variable. This fourth step, this is one that you cannot skip. This is actually important. You need to check your solutions. Why is this? If you have a radical equation and then you exponentiate both sides, so this means you're raising both sides to a power, you are creating a brand new equation. We need to check our solutions because the solutions that we obtain in this manner, not all of them will be solutions to the original radical equation. So I'm going to follow these steps here in order to tackle this problem. It says here I need to solve for x. Okay, so how do I do this? Following the steps. The first thing that I have to do, I have to isolate the radical. So this square root 12 minus 2x, I need to get it all by itself. So I'm going to subtract 2 on both sides. If I do that, I have square root of 12 minus 2x equals x minus 2. Now that I have the radical all by itself, what do? I need to raise both sides to the power of the index. This is a square root, so I will square both sides. Since we are squaring a square root, the left-hand side has no radical. What about the right-hand side? On the right-hand side, you have x minus 2 quantity squared. We need to FOIL this. Foiling the right-hand side, you have x squared minus 4x plus 4. Now what? So I followed steps 1 and 2. I need to go through with step 3. I'm going to move everything over to one side. So I'm going to subtract 12 on both sides and add 2x to both sides. I'm going to scroll down here. Once I do that, I have 0 equals x squared minus 2x minus 8. This quadratic equation on the right-hand side will factor. It will factor into x minus 4 times x plus 2. Solving for x, we now have two equations. X minus 4 equals 0, and x plus 2 equals 0. Solving for x here, you have x equals minus 2, and x equals 4. We are not done with this problem. The fourth step states that we need to check our solutions with the original equation. So the original equation was 2 plus the square root of 12 minus 2x equals, what did that equal? What does this equal? Oopsie, one moment here. Equals x. So I need to check my solutions here. Let me color code these two solutions. So this guy I'm going to write in blue. This other one I'm going to write in hot pink. Checking our solutions, let's see what we have here. So with this guy in blue, I run into no problems. 2 times 4 is 8. 12 minus 8 is in fact 4. Square root of 4 is 2. 2 plus 2 is 4. No problems. No problems at all. So this guy for sure is a solution. Let's check the hot pink now. Okay, so here we run into problems. Inside the radical in the hot pink, you have 12 minus 2 times minus 2. That's going to simplify to 16 inside the root. And the square root of 16 is 4. And 2 plus 4 does not equal negative 2. Let's take a look at that really quickly. So this one obviously does not work, right? 2 plus 4 does not equal minus 2. So your only solution then is x equals 4, and I had circled that here. So it's extremely important when we tackle these problems that we check our solutions. So I'm going to work on another problem before ending this video. you have the cube root of 1 minus 2x equals negative 3. The first thing that we have to do is we need to isolate the radical. We now need to exponentiate both sides by, I'm sorry, wrong choice of words. We need to raise both sides of this equation by the index of the radical. The index here is a 3, so I will cube both sides. My left-hand side simplifies to 1 minus 2x. My right-hand side will simplify to 27. So now I will just solve for x. And here I ended up with x equals minus 13. Once again, I'm not done. I need to plug this back into the original equation to see if it works. Plugging this back into the very beginning, let's see what happens here. 2 times negative 13. Oh, there's a negative there. So we have 1 minus 2 times negative 13. That's going to give you 1 plus 26. Inside the root. And the cube root of 27 is, in fact, 3. So our answer is x equals negative 13. Alrighty, everyone. That concludes our introductory lecture video for section 1.4. And I will see you in class tomorrow.